Right, good afternoon, and thank you for the opportunity to speak to you about the Lakeland Industry and Community Association and its air and deposition effects monitoring programs. So I'm just going to start with a little introduction about LICA. We were formed in 2000, and LICA is a monitoring organization. We are Alberta's seventh airshed monitoring airshed organization, and we received endorsement from CAS in 2005. But before we were a monitoring organization, we were a synergy group and still are a synergy group. And it was formed in 2000 as a means or forum for industry, community, and government to come together and discuss regional development issues. So the region is described on this map. If you look at this this map, you might think we're a little strange in that we've got three sets of boundaries, but the LICA organization is an umbrella organization for the LICA Synergy Group, the LICA Airshed Zone, and the Beaver River Watershed Alliance, the WPAC, for the Beaver River Watershed. While the airshed is primarily a monitoring focus, the WPAC is primarily a watershed management planning and education focus. Those that live here know it, and those that visit the region recognize it, but this is a special region of Alberta, characterized by an abundance of lakes, natural beauty, a colorful cultural fabric, and coexistence of these features with development in the region. So hopefully some of these pictures illustrate that for you. And that concludes my tourism promotion portion of the presentation. Some unique characteristics of the LICA region. We are similar to Wood Buffalo in that it's an oil sands region, but we don't have open pit mining. It's primarily an in situ production area in its various forms. So there's thermal production and cold heavy oil production. Agriculture is a very big part of the landscape. So is forestry and the cold air and the Cold Lake Air Force Base. The Cold Lake Air Weapons Range takes up about a third of our airshed zone. So I'm going to provide you an overview of our monitoring programs. Our core monitoring programs include the passive monitoring network, our continuous monitoring network, the pH and VOC monitoring programs. I'll also talk to you about our deposition programs, so the soil acidification and surface water acidification, and a couple of special studies, including integrated PM and Beaver River Valley monitoring project as well. So our passive monitoring network was established in 2003. It generally follows a 3x3 township grid. There's a chevron missing on my timeline on the bottom. The monitoring program actually started in 2003, but was enhanced in 2006. In 2006, we also added continuous monitoring, and the continuous monitoring stations are represented by circles on this map. We monitor continuously in Cold Lake, Masqua, which is in the in situ thermal operations area, St. Lina, and we have one portable monitoring station, which is currently at Elk Point. 3 of the 4 stations can report on the Air Quality Health Index, and we also collect imagery as a qualitative assessment of air quality as well. We also have pH and VOC monitoring at our Cold Lake and portable air monitoring stations. We also implemented, so this is getting into the deposition effects monitoring, so we also have soil acidification monitoring going on at 3 LICA-operated sites, and we also consider the Alberta Environment site at the Cold Lake Fish Hatchery, or near the Cold Lake Fish Hatchery, as part of an important part of the regional program as well. And now onto the surface water acidification monitoring. Now, we don't do a whole lot of surface water acidification monitoring, but everybody else does. So we use their monitoring data to answer our questions about surface water acidification. However, in 2014, we added a subset of lakes to that existing monitoring to fill in a couple of data gaps in areas of high deposition and for lakes that are deemed as being acid sensitive. The Integrated particulate matter sampling project is something we're doing to transition from an older monitoring technology to a new monitoring technology. It's a co-location of the federal reference method in Cold Lake. It'll give us an opportunity to characterize Cold Lake particulate matter as well. And our Beaver River Valley Monitoring Project is a special stakeholder concern about valley flows and the effect that that is having on air quality within the Beaver River Valley and as well as visibility. So generally, the objectives for our monitoring programs fall into these. Well, these are the objectives of some of the objectives from the JOSIM plan that our monitoring programs help to meet. Provide stable long-term monitoring framework to observe changes, provide regional information on current status and trends of contaminants of concern, and allow better understanding of long-range effects of air emissions downwind on, for example, acid-sensitive lakes. So what we're looking at here is a dashboard style report for all of the continuous monitoring for 2014. Each row represents a station and each column represents a parameter. I realize you probably can't read the finer text, but for this presentation all you really have to see are the patterns. The first column is nitrogen dioxide. We saw something in the passive monitoring network that we didn't expect, and we saw high in nitrogen dioxide down at our Elk Point station. We decided to move the continuous monitoring trailer down there to give us a higher temporal resolution than passive monitoring could provide with us. And I'm going to go into some detail about Elk Point later on in this presentation. When we move that trailer to Elk Point, if you go over to the third column, you'll see that we had particularly elevated hydrocarbon concentrations, which is something else that we didn't expect to see at that station. And I'll talk to you about some special analysis that we did to help us understand that. We've also had an eye on St. Lina monitoring station, and looking at the second last column, it was Ozone. We consider this station to be our background or inbound transboundary station. Based on at least Ozone, it's likely, seen here, it's likely a good candidate for further enhancement of monitoring if more upwind data are needed. We don't see the complete titration of ozone at this station like we do at Cold Lake and our other monitoring stations. And lastly, on this slide, the last column, this is the air quality story of 2014, was the poor air quality episodes in the summer due to forest fires. We had extended periods of poor air quality because of the forest fires burning in Western Canada and in Northwest Territories, and we saw that in our monitoring data for the better part of a month. This slide shows our passive monitoring data for 2014. These are annual averages. The first chart shows the elevated nitrogen concentrations down around Elk Point, which is it's something that we see in the continuous monitoring data as well. Sulfur dioxide is the second chart, and we see the elevated concentrations there where we would expect them to around in situ operations. And ozone, typically ozone measurements are high where nitrogen dioxide measurements are low, and that is something that we expect to see. And the last chart is H2S, hydrogen sulfide. In hydrogen sulfide, we see two things. We see H2S high near industry, but we also see H2S high near feedlots and other agricultural sources. So we're going to take a closer look at Elk Point and some of the work we did in 2014 to understand the higher concentrations of hydrocarbons at this site. This box plot just shows all of the hydrocarbon monitoring data diurnal patterns at our 4 monitoring stations. It's probably a bit small for you to see, but if you're just looking at the middle 50, the quartile range, the Elk Point shows the highest concentrations of hydrocarbons, which is something that we didn't expect to see, particularly when the Mascwa station is really on the doorstep of large oil sands operations. We tried to do some back trajectory modeling to figure out potential sources. And this is back trajectory modeling based on 2013 data. However, 2014, generally speaking, we saw the same trends. So in this chart, the red square represents the location of the Elk Point station. And it was a simple exercise to try and determine the origin of elevated hydrocarbon measurements. So the origin of each of these 2-hour back trajectories is within 10 to 20 kilometers of the station, and sometimes even closer. Very simply, what we saw, especially if you remove those two long events out the west and out the east, that a lot of the measurements you can't correlate. We couldn't correlate a direction or a source or pinpoint where it was coming from. And if we run several back trajectory runs on a number of high concentrations, there was no pattern showing up in the analysis. So what was causing this? Based on the trajectories and on the high density of oil and gas activity in the area, it appears that the higher concentration observations are a function just of intensive cold flow activity and the associated fugitive emissions from those sources. And this map here shows the red square in the middle is the location. On the left map is our St. Lina monitoring station, so it's our background monitoring station. In Elk Point, where we saw these elevated hydrocarbons, you can see the density of wells and batteries around that site is quite high. So it's a collective, or the cumulative effect of all of those sites being detected at the station. So future monitoring considerations for Elk Point. Locally, we know that improvements are being made to mitigate fugitive emissions from cold heavy oil production sites, and LICA may choose to return to the Elk Point site to do follow-up data collection. The station that is at Elk Point right now is our portable monitoring station. It is due to be moved. So I'm going to move on to talk a little bit about our deposition effects programs. One of the objectives from the JOSEM plan is to improve analysis of existing monitoring data to develop better understanding of historical baselines and changes. In 2007, I like to think that LICA was thinking about doing this ahead of before JOSEM came around, and we commissioned a study to compile and analyze existing data about deposition or potential acidifying emissions, and create or estimate potential acid input, assessment of surface water sensitivity to acidification, and as well as soil sensitivity to acidification. So these are some of the products, deposition effects, or deposition assessment products, sorry, and these are detailed in our poster in the poster session, if you'd like to take a closer look. But we did look at soil and land sensitivity, gross critical loads of lakes, and potential acid input. So this led to an interest in taking a closer look at what was going on at the Alberta Environment site. Alberta Environment has a monitoring site near Cold Lake. It was established in 1982 with 8 sampling events that occurred from 1982 to 2013. pH and base saturation have shown reductions in the top 2 centimeter during this period. pH is decreased from 4.8 to 4.3, and base saturation decreased from 95 to 85%. So there's a potential acidification of the soil happening in the uppermost layers at the Cold Lake site. So that was a trigger for LICA to figure out, triggered a concern, I guess, to find out, is this trend continuing at the site, and is it happening at more widespread, I guess, sites across the region. So we established 3 more soil acidification sites in areas of different differing deposition, so high deposition, low deposition, medium deposition. So it increased our monitoring coverage of regionally sensitive soils. It improves our understanding of spatial variability in potential acidification, and determine, and like I mentioned, to determine if acidification trends in the existing ESRD site continue and if similar trends can be observed regionally. I'm out of time. Three more minutes?
Yep.
Okay. So the three sites that we established are the Moose Lake Provincial Park site, the Whitney Lakes Provincial Park site, and the Tucker Lake forest plot. And these are they're a staggered sampling interval once every 4 years. We're currently, in 2014, we just sampled the Moose Lake site for the second round of sampling. So in terms of deposition effects, like I mentioned, we did in the first, in 2007 and 2012, we did assessment of surface water sensitivity to acidification, and we used data from other sources to answer questions about surface water acidification. We identified 12 lakes that were in areas of higher deposition and also potentially acid sensitive to complement those already 64 or so lakes that were being sampled by others. So in 2014, we sampled 6 of those 12 lakes, or attempted to sample 6 of those 12 lakes. So we sampled 5 and 1 was inaccessible this year. All of those lakes generally had high buffering capacity. And we're below the monitoring trigger level. Concentrations at one of the lakes were lower than, concentrations of calcium at Bear Trap was lower than other lakes, giving it a moderate sensitivity to acidification. And at Whitney Lakes, Whitney Lakes is a, and I should have mentioned this earlier, but, and I think Bob Cameron talked about co-location of different types of monitoring activity. Our Whitney Lakes soil sampling, there's a Whitney Lake soil sampling site, and we're also sampling Whitney Lake itself, and we're also have passive monitoring going on in that area. So we're trying to layer that monitoring so we can see if there's changes in ambient conditions and changes in the environment as well. So at Whitney Lakes, we sampled that, and we found that while it's in an area of higher potential acid input, it also had generally low critical and net critical loads. So that's the end of my presentation. There's many ways to keep in the loop with LICA. I think I have about 3 minutes for questions.
Any questions?